So my name is Bill Wilson. I'm a new product development manager for Molex. Today we're going to be talking about internal cable solutions for servers, but specifically SFF TA-1026, which is the SFF name for what we call near-stack PCIe, but in all the OCP documentation, it's known as and referred to as TA-1026 just for cohesiveness. And then just to demonstrate kind of the standard solution and then what we're doing to customize and to optimize it for the DCMHS ecosystem. So just from an overview, I'm going to start off with just a product summary to, I'm not sure how many of you are familiar with the product itself, so start with just kind of a TA-1026 introduction, and then go through some of the things that are requiring innovation on our end, right? So requiring some changes to the product to make it compatible with the pinout or with some mechanical specifications, and that's going to be for the by 8 size. And then also talk about MPIC, which is has an optimized boot optimized connector cable solution within that specification. So we'll get into the details of that a little bit more as I go along, and then we'll just kind of finish out with a summary of the information. So what is near-stack PCIe / TA-1026 as it's known? These are kind of just some general images of what the product is. It's a high-speed by 8 connector solution today. This connector sits on your circuit board up on the top left there, and then there's multiple cable assembly solutions that will mate to that connector. The cable assembly is available today in right angle, angle exit, and vertical exit. And you can see the mating interface there in the middle. I have a few more details on that on some upcoming slides, and then just some better images of the cable itself over on the right side. So basically what we're talking about is you'll run into a lot of stuff, obviously OCP server related today and tomorrow, but this is specifically internal cable solution for your server running Gen 5 PCIe. So from an electrical, mechanical, and availability standpoint, like I mentioned, Gen 5 PCIe with a bandwidth to Gen 6. Connector and twin-ax are designed at that 85 ohm impedance that's necessary for PCIe infrastructure. There are 18 differential pairs and 16 single-ended signals in the pinout. That is compatible with TA-1016 and TA-1002. So we can create hybrid cables with near-stack PCIe on one side, MCIO or sliver on the other side for intercompatibility between devices in the systems. The differential pairs are run over 30-gauge twin-ax. The sidebands are run over a 34-gauge ribbon wire. And I'll talk a little bit more about that on an upcoming slide. That's one of the things we're modifying a little bit for the OCP FLW. The MXIO pinout requires differential signaling on some of the sidebands, so I'll get into that in a slide or two. And then the dense overall envelope. One of the main kind of selling features of this product is the right angle cable has an 11.1 millimeter mated height, which is lower than anything on the market when it was released. And we'll also talk about the mated height on a couple of slides as well. So we designed this one with a metal cage around there for robustness, and we actually surpassed a 25 Newton wrench test in multiple axes. Not only passive wrench testing, but active wrench testing. So we hooked these the SI test boards with a mated cable up to the VNAs and do the wrench testing while we're taking measurements, and have passed all of those tests. So very robust solution, very high-speed solution. And currently available, like I mentioned earlier, by 8 in right angle, angle exit, vertical cables. The board side connector is fully tooled, and we're second sourced. We're in the SFF project TA-1026. We're recommended on the FLW as the far end IO interconnect, which I also show on an upcoming slide. And then we're also on Intel Blue Sheet for PCIe Gen 5. So good adoption there and good recognition by the market of the solution. So just a more detailed look at the product here to break out kind of the segments of the solution itself. You can see there's a high-speed section with the differential pairs there running over the twin-ax, and then the ribbon cable running the single-endeds, and that also kind of translates to the picture of the connector up there on the right. And so you'll see here some of the highlights. What differentiates this product from other things on the market? The main thing that near-stack does as a product, and this applies to other versions of near-stack as well. So near-stack PCIe is just one of the sections of the NearStack product family. There's a bunch of different solutions that we offer within the NearStack product family. All of them have this direct-to-contact weld termination. So we remove the paddle card from the assembly. So historically on these types of cables, and even today, you'll see on like TA-1026 and 1002, there's a small paddle card in the cable. So the wire terminates on one side of the paddle card. It has gold fingers on the other side of the paddle card, and that's used as the mating interface. So we remove that PCB, that small PCB from the cables, and replaced it with a direct-to-contact termination. So you can see up there in the top right, those wires come in from the back and they're terminated to that signal wafer directly. So there's no more need for that paddle card in the assembly. So that's beneficial from an SI perspective and from a repeatability perspective. Secondly, it has a unified ground structure, so we actually have stitched grounds into the wafers, which is good for signal integrity, both on the cable side and then on the connector side. You can see I magnified it here on the right. The ground structure is all unified there in that high-speed section, so you can see all the commonized ground. So this is good for crosstalk and isolation of the differential pairs. And then finally, it has a little bit of a unique mating interface there with the flexing beam on the cable side and the fixed side on the board side connector, which was a little bit of a divergence from what had been done previously. But this has some benefits as well. So kind of getting into, well, I'll show a little bit of the SI here. So this is the SI performance correlated, measured to simulated. So our performance is good and measures well according to our simulations, and we have all these files and documents available if customers are interested in simulating or measuring our product today. So getting into kind of how does this relate to OCP and why are we here talking about this today. So in the DC-MHS larger specification, there are two subsections called FLW and then XIO. And so per FLW, which is the full width specification for the motherboard, the far side IO mechanically has to be below 12 millimeters. And our standard version with just the thumb latch is already at 11.1, but the pull tab version is slightly taller. So I'll show how we're going to be changing that. And then per MXIO, the pinout needs to support differential signaling in the sideband area. So it calls out these flex IO pins on pins 37 through 44. So to support those things, all right, so this just shows here that we are recommended on there. So this kind of just points out SFF TA-1026 in that far IO connector zone. And so to show kind of that height to support that 12 millimeter mated height, we currently have these two options on the left, bottom left and kind of middle. One is 11.1 millimeters, as I mentioned. The standard offering that's tooled today for the pull tab is at 12.3. We didn't have that 12 millimeter cutoff when we designed that, so we didn't really know we had to be below any specific height. So now that we have that knowledge, we're going to be revising that height overall to 11.75, which isn't a major change. It's just a small molding change for the cable top housing. So this will be offered to support that FLW spec, and it actually might become the standard offering as well, because if we have the 11.75, we don't necessarily need to support the 12.3. And then as well, this is kind of what I mentioned earlier about this differential coupling of the flex IO signals in the sidebands. This is just kind of some of the language from the spec that are requiring that flexible pin out there to be differentially signaled. So what we're doing is we're replacing that ribbon cable, as you can see here on the bottom left. So there's two layers of ribbon cable in the cable assembly. We're replacing that top layer with two twin acts here, with 34 gauge twin acts. So we'll be compatible both mechanically and electrically with that the DC-MHS spec, and this cable can be fully used and attached on that FLW motherboard as a far end IO solution. And this change has no impact on the connector footprint. They both mate to the same connector. So you can design in that connector today, and we'll have that cable that's compatible with that pinout available in Q2. All right, so jumping a little bit into a separate topic. So in MPIC, there's a new recommendation for an optimized boot connector cable, and this is for hard drive boot. So the idea there is that historically, if you wanted to have a boot drive in your server to boot off of specifically, you had to connect that back to the motherboard somehow, and everybody was doing different things. Some were using, high-speed cable, low-speed cable, power cable, all separate, and everybody was off designing this their own way. So in this spec, there's a specific recommendation to use a solution now based on TA-1026. So there's a requirement for high speed, there's a requirement for low speed and power, all within the same connector. And this can all be found in the MPIC 1.0 in section 9.2. So you can see some images here. These are taken from that spec. And you can see the high-speed section is, I know this laser is not really showing up that well, but the high-speed section is at the bottom here, low speed is in the middle, and then the power is up at the top. So what we're doing is we're offering, and this is now in that spec, and we're going to be offering a solution of a by-4. You can see the high-speed section there, which is 10 differential pairs and 12 single-ended signals. I've titled this Section A. So that's all based off of the existing 1026 contact design. So that uses the high-speed signals and the low-speed signals we already have in production today. The only new addition is this Section B, which is the power blades. And we're reusing some technology and contact interface from other products. So it's not kind of redesigning the wheel. We already have experience with that type of a power blade. And we'll be offering this cable in both a vertical and a right angle solution. So ideally the right angle would go on the motherboard, the vertical would go up on the other device for a kind of a backplane style of interconnect up to that hard drive location. So this is going to be the recommended solution for that optimized boot drive within that MPIC specification. So we plan on having this cable and connector both available in early 2023. We are working on the final design on that and releasing the tooling for that shortly. And all these part numbers are going to be called out in the OCP current connector list. So that's on the wiki page, and you can find all that information there. So kind of a cool iteration, proliferation of that standard TA-1026 product family to provide a unified solution for power, high speed and low speed, all within the same cable, and allow server manufacturers, developers to all standardize around a single type of interface there for that application. So in summary here, I kind of broke it out into a couple bullet points about the standard product and then the specific stuff we're doing for OCP. So in summary, TA-1026 is an innovative high-speed cable connector product for PCIe Gen 5, Gen 6. So this is something we currently have in full production. We're shipping today. So you can find this on our website. It's going to be there under NearStack PCIe. So you can find part numbers and more technical documentation on our website. As I mentioned, Cable Design removes the paddle card from the assembly and optimizes that wire termination process to improve repeatability, signal integrity, and create an attractive cost profile on the product. And like I mentioned, fully tooled and available today. So to support OCP and the DC-MHS infrastructure, we've continued to innovate and develop modified versions to support these various specifications, including the lower profile height version, both in the pull tab and the thumb latch version. And the good thing to note is all of the stuff from in that lower profile scenario, it all passes the wrench test. That's just slightly changing the mold tooling for the top cover, but everything we have that's tooled today is going to be similar in performance mechanically to the new stuff is all going to be similar mechanically. So we're not going to have to go back through and do new qualifications, new testing, new mechanical criteria on those. That's all just based off of the standard product that's available today. And then this MPIC cable optimized boot peripheral connector and associated cable assembly are based on that known TA-1026 design, turning that into a by-4 and adding power to provide a solution for that specification. And then just as a final point, obviously Molex is committed to tooling up and supporting all connector and cable solutions outlined here. So we're going to continue to partner with OCP, with the various manufacturers that are here today, and with anyone interested in this solution. We'll be having these products tooled and available in the market in the next few quarters, in addition to the stuff that's already available as a standard product offering today. So any questions, any comments? Have about a minute left, so feel free to ask me anything. If not, we can close it out and you can enjoy the rest of your day. No? All right, thanks everyone.